So CPES is the Center for Power Electronic Systems, and essentially what power electronics are is just they focus on the conversion of energy and power from one form to another. So it's just as simple as like converting alternating current to direct current, or like changing the frequency of a source. But they're really important because they're really used everywhere. Like if you think about it, power is always being changed from one form to another. Like if you take solar panels, like they get energy from the sun, and then the power electronics within the solar panel convert that energy to be usable, for example, powering our house. Or like when an electric vehicle is charged, that charger is using power electronics to convert the grid's energy into energy that can be used by the car. So I've worked at CPES for the past almost 3 years actually. I started there my junior year of high school when, after I went to CTech Square, the camp, I met Dr. DiMarino. I reached out to her. I put in an application to be an intern. She accepted me, so grateful. And then that summer I began working there. So my first project I worked on Scaled, which is a substation in a cable for adaptable low-cost electrical distribution. And essentially what that is have you ever driven past like those really bulky substations? And essentially what it's going to do is it's going to take all that and put it into like a meter or 3 meter long cable, and it's going to completely replace them. Because America's current electric grid is really, really old, and it's really susceptible to power outages, and it's just breaking down kind of. So what Dr. DiMarino and CPES right now is aiming to do is kind of make it more like adaptable and low cost. And so for that project, what I did is I was in charge of creating a CAD model of capacitors that was driven by a Python script, and I had to completely like learn new software. I had to learn Python, and then my project would be used for like electrical and thermal simulations. So you could put in the voltage and the capacitance that you wanted, and it would like spit out the ideal capacitor that you wanted. And so that was really cool. I learned a lot of new skills. Then my second summer, I got to do really, really fun high voltage testing. So we went up to, I think, 20,000 volts, and what we did is we had heat pipes running through like the Scaled module used for heat dispersion, and they were really close to an aluminum heat sink, and there was insulation between them. But if the voltage got too high, there could be a breakdown. So what we did is we put those heat pipes in like a testing chamber, and then we ran voltages through them and the insulation to see like when it would deteriorate. So that was really fun because I got to say that I worked with voltages of 20,000 volts. And it was just really cool because it was so hands-on, and it was such like a real-world experience that I wouldn't ever get in the classroom. So I was really grateful to be able to work with my PhD student Mark and get that experience there. And then currently now, over the school year, my undergraduate research, I'm doing a life cycle assessment of a power electronics building block. And what that is that we take this power electronics building block, which is just like a power processing unit, and we break it down into its like most simple components. Like we break it down into the transformer and the capacitors and like the metal casing and stuff like that. We put it into a software, and then we see the environmental impact of it. And we see over its entire life cycle, like how many carbon emissions does it spit out, like, and what can we do to improve that? Like what components contribute the most to this environmental impact, and how can we redesign the building block in order to be more environmentally friendly? And then we're working with Hitachi Energy on it, and then we're gonna write up a journal report and publish that on our findings. Yeah, I'm just really grateful for Dr. DiMarino and CPES and all the students, because they're all so incredibly sweet too. Like they're all so happy to teach me all the time. If I have a question, and I had a lot as an intern, they were always so happy to help, and I was just really grateful that I got to start electrical engineering in an environment like that, because it made me so passionate about it. Because if it was a bad experience, I probably wouldn't even have chosen the major. First, practical lessons. It's like the communication of your results. I've learned how important it is to effectively communicate like what you've worked on, because at CPES I've had to make a lot of presentations, and like now I'm writing an academic paper, and it's so important to be able to clearly communicate to the audience like what you have done. I've learned to like get rid of any redundancy and like use a lot of images, and I think that a lot of like as an engineer, I feel like we're always, maybe there's like a stereotype about like communication like that, but it's so important to be able to communicate as an engineer. Learn how important it is to step out of your comfort zone, because when I started working at CPES, honestly, I felt like such an imposter. I was like, there's no way that like I can do all these projects. I mean, all the PhD students are so smart. How am I ever gonna code a CAD model? But once you get into it and you jump into it and you just really try to challenge yourself, there is so much you can learn. So I think that it's like given me confidence in trying new things and like not being scared to try something, even if it seems really difficult.